Moving data to RavenDB from a relational database is easy. Moving your mindset from rows and columns to documents takes a little work, but the benefits are worth it. A developer can work for years, even decades, using relational databases in his projects. The assumption behind all his work becomes cemented into his mind like unshakable pillars of truth. Upon entering the world of document data, most of these pillars shatter to bits, opening up a new realm of possibilities. Especially in the business world, where it's natural to think in documents, each handling a specific event. It can be a purchase, a contract, a lease, a hire, a sale, just about anything. Once that event happens, even if it's modified, it has its own existence. It's more organic than disassembling pieces of each document and scattering them across an array of tables. The more you work with your data by associating events with a document, the more enhancements begin to materialize. Your data ops become leaner. You process information faster. You require less investment and overhead to offer more to your users. Today, RavenDB CEO Oren Eini shows you how to get the most of your document database by taking advantage of what you can do with ease by embracing the modern way to model your data. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi, everyone. Thank you for showing up for this webinar. This is an interesting webinar because I'm not actually going to talk about RavenDB specifically, at least not in any great detail. What I want to be doing, I want to give you some background about what were the things that impacted the design of RavenDB in applications from almost day one. To give you some background and history, I used to be a consultant. I would go to a company and tell them how to better build their business applications. And one of the constant limiting factors was the database. And one of the constant limiting factors was how complex and hard it was to deal with that. Now, if you think about it, applications in the 80s, green screen applications were conceptually very simple. The most complex user experience you had to deal with was the master details forms. Today's applications are dealing with vast amount of information, with really complex data sets, and with increasingly higher demands from our applications. As a user, regardless of what application I'm using, I'm measuring your applications, not against your contemporaries. I'm measuring your application against the giants. Oh, you have an application that does something like email. You have too much Gmail for the feature set. Oh, you're looking into something like a social network. Facebook and Twitter are the things that I compare you to. And that has a lot of impact. It has a lot of impact in terms of the richness of features, the simplicity, the user experience, the latency requirements, all of those. Now, that also has an issue because presumably you don't have the budget of Google. At one point, I was talking to a customer and he kept saying, oh, I need to do it just like Google and stuff like that. So I went and pulled the SEC reports for Google for that year. And the development budget at Google was something like 19 billion. So I sent him a pro forma invoice for 19 billion. And apparently there was an automated process around handling invoices, even pro forma invoices. And that kicked off a lot of nonsense because of that. But I got my point across. You need to have reasonable expectations. And then the next day, oh, I want it just like Google, because this is what you have to meet. This is the requirement. The good news about this is that if you don't have to deal with Google or Facebook or Twitter scale offload, there are a lot of really good options for how you can manage and work with your data. So let me give you some examples. We're going to be talking about building business applications because that's usually the bread and butter of what we're talking about. And one of the things that I've tried very hard to do when designing RavenDB is to look at it from the outside in. Here is a feature that I need to build better business applications. So it's already in. You don't have to jump through hoops to get it. Let's look at the start. The number one problem that I see when people move in to RavenDB is a very simple one. Decades and decades of relational experience. This is how people model the data. There are rows, tables, columns. That's the way it is. And you know that you have to build the schema. You know that it has to be at least the normal form. And for most people, this isn't even something that they think about. This is just something that they do. That's the way the world is. So let's think about that aspect for a second. What sort of applications are we actually building? And the more complex we have to deal, the more complex the data, the harder the database has to work. By the way, when I'm talking about work, I'm talking about development work for developer needing to build the queries, the join, etc. DBA is needing to make sure that all of the indexes and options are in place, and for the database to actually do all of this work. Now, it's very common to have complex data structures today. Think about the humble invoice and how much complexity is hidden behind, a simple piece of paper. We need to deal with data that is different based on different entities. If I'm building a product catalog, then there are very different fields for the pen versus the phone. So that makes things more complex because one of the issues with relational database is that they are rigid. By the way, as a database developer, it's so much fun to have a fixed schema. You have no idea. It's like it makes things so much simpler, so many opportunities for optimizations. But we deal with that. One of the more painful aspects that we have to deal with is changes over time. And that's actually really important. There is this great book. It's called Refactoring Databases. It's implicitly refactoring relational databases, and it's 350 pages long. And it contains all sorts of really interesting recipes about how you can refactor your database. In a word, it's complex. And you have to take a series of very specific steps in very specific order in order to make sure that you're not breaking stuff. Now, that's a huge problem because there is a major question that we have to deal with. When are we making decisions? When are we deciding on the layout of our schema? And the answer to that is that we do that at the very start of a project. That's probably the very first thing that we're doing. I mean, otherwise we wouldn't be able to even do anything. The problem with that is that now you have to deal with the complexity of modifying things. Oh, I need to make sure that if I'm adding a column, then I'm doing that in a way that wouldn't break existing queries. I have to have a better overall view of everything that is going into my system. So queries would use the right indexes, and the statistic would be up to date, and a bunch of other stuff like that. You might, if you're a developer, you're not familiar with this, but this is a large part of what the DBA actually do on a day-to-day basis. And this is complex, this is fragile, and if you don't do this properly at certain loads, you just fall over and die. Another aspect that you have to deal with is that the relational mindset, and this is one of the key issues I think that we have to deal with, are forcing us to model the data in a way that match the database. Now, this has a distinct advantage because it also means that to a certain extent, I can store the data in the way that the database prefer, and then project it out, query it out of the database in whatever format I want, to up to a point. The problem with that is that the way that the data is stored and the way that the business perceive this data is often completely different. And that's a huge issue. Going back to the invoice. Invoice has charges, the things that are line items. Invoice has payments, fees, taxes, discounts. And this is a fairly simple invoice. I might be using credit from a previous transaction to pay for this invoice. I might have to do a whole bunch of nonsense around fiscal years. And suddenly my invoice is sitting on 30 tables. That's 30 tables. Try to imagine how many queries you need to issue and how many journals are involved in order to print a simple invoice. For that matter, try to imagine how hard it is to ask questions on this data. So we don't. So we have to use ETL processes, extract, transform, load, to move the data from its relational format to star schema, to OLAP cubes, to be able to question it there. And even if I'm still staying just in the OLTP mindset, just in the business application scenario, developer has to work quite hard in order to translate between the database format of the data, the way that the database structure of the data, versus how we want to display and operate over the data. That has huge cost in development and in runtime. If you use an object relational mapper, such as an Hibernate or Entity Framework or a Hibernate in Java, a JPA, all sorts of stuff like that, you will know that the richer the domain model is, the more traps you have waiting there. And it's very easy to get to the point where you're hammering the data with completely ridiculous amount of load. I once went to a customer and I observed 17,000 queries to render a single page. That's 17,000. Absolutely insane. And I'm actually shocked that we're actually able to process that. Most of the queries are trivial, but still. And they effectively have no idea, no way of digging them out of the system. What I end up doing is creating a service that would hold those documents, hold all of those data in memory as complex objects. Now we would call them documents, and persist them in the background. That was 2008 or something like that, before RavenDB. But it meant that instead of having to face 17,000 queries, their page load was 3 queries to the service. And their latency went to effectively nothing. Now, this is all well and good, but I want to focus on specific scenarios. I want to look into how we solve business problems in conjunction with a document database. So let's look at the hotel reservation system. I like the hotel reservation because it's relatively simple. I have hotels, I have rooms. Rooms have features, they have things like what they have in the minibar, and not that interesting. I have availability for a particular room, and then I have the invoice. Now, look here. I have charges, and I have all sorts of different rules for the charges. The pay-per-view charge, I'm not going to show you what movie you purchased. The room charge is obvious, and the minibar, hey, you picked out on nuts, pay up. In the case of payments, you have maybe the user is paying using multiple credit cards, cash, credit from a previous previous visit, or they're paying with points or whatever. The key here is that each one of those is a distinct and separate object. Now, if I'm trying to model that as a relational database, this is what I would end up having. Invoices table, and I have minibar charges, pay-per-view charges, room charges, etc. For payments, I have payments, and then I have a type field in them. So those are the two common ways to handle a polymorphism in a relational database. Either you have a discriminator field, like this thing, or you have multiple tables, like this case. In both cases, this becomes really, really complex. Queries on this, if I'm using a discriminator, are going to produce very wide rows. Queries on this needs to union or join between multiple tables. That's really, really complex. That's hard. But think about this. How do you model that if this is a document? Each invoice is a document. And now I have a charges field. And in here, all of them are in one place. Now, this seems like a ridiculous distinction to make. And it is. I put all of those details in one place. Why does it matter? It matters because think about what it means from the point of view of the developer. I'm loading an invoice, which is a JSON document, which gets hydrated into a complex object graph with full capabilities such as, oh, here I have room charge type. And those are polymorphic on that. Payment, those are polymorphic on that. I had one query to load everything up. Now, that has implications on two fronts. On the one hand, when I'm querying the data, it's easy. Give me all of the recent invoices for customer XYZ. It's that. I don't have to think about it. It's simple. From the point of view of the database, it means, okay, let's go and filter based on this date, based on the name, whatever, and I'm done. I got the right values, I'm there. The fact that we are not having to split the data into so many locations frees a lot of resources for the database, for the developer, for the architect, for the DBA. Things become easier to use, simpler to operate. Now, there is still an issue. You can see here that I have an availability. Now, in this case, I have a room and the room has the set of features that are interesting. Now, I have an availability here of the dates that this room is available. I want to go and query on that. So I want to say, give me a room that has a poolside view on those dates. And that would match it. Probably need to be greater than or equal, etc., but that would match it. Now, notice that in here, I'm saying I'm indexing over this is the index, this is the query. I'm indexing over the availabilities and loading a related document in here. Now, it is possible that they have some amenities that are only available at specific dates. For example, let's say that there is a concert by Shakira at a particular date. And I want to say, hey, you can sit on the balcony on this room and see Shakira. This is not generally available here. So I can say, hey, let me add a feature to the availability itself. And now I just need to merge room features and the availability features. Everything else is just the same. Notice a really key aspect that we have to think about it. Referencing related documents is not hard. It's not costly. I can just do that. I can do that during indexing. And by the way, RavenDB ensures that if the features of the room change, we would re-index the appropriate availabilities. It also means that when we think about the way that the data is structured, it's almost identical to how the business is thinking about that. That makes things so much easier for us. I can go and you know what? I can print a JSON document. Well, not print, no one prints anymore, but I can show the JSON document to a business analyst. And we can have a discussion on what this particular field mean and how to use that and all sorts of stuff like that. That makes for a much different interaction with the business. And this is funny because I'm talking here as someone who is dealing with databases. I'm talking about what sort of interaction you have with the business. But it matters. It matters because it so significantly reduces the amount of headache and ulcer that you'll get. It also has other advantages. With relational database, the more data, the more tables you work with, the more joins. You end with quotation products. You end with really expensive queries. With RavenDB, none of that applies. And so you don't have complexity, you don't have much of the cost. Now, a caveat here is about the notion of scope. It's tempting sometimes to say, oh, let's just put everything into a single document. But this isn't how you actually do the sort of things. Think about something as simple as the entry log into a building. You go in, you sign that you went in, you sign when you went out. About as simple as you can imagine. But they're not going to store that information on one single page forever. Every day, every week, every month, they're going to give you a new file. Because otherwise, just looking over the entire data set is too complex, become too unwieldy. So we have to think about the size of the documents involved. If we go back and look at this, let's say that I'm ordering a bunch of rooms. I have a wedding, I want to order a bunch of rooms, and I'm paying for them. The invoice may contain, 20, 30, 100 rooms. Or I'm doing a conference, I'm needing 300 rooms. The invoice would hit, you know what? Half a megabyte at top. Still workable. But if I need to, I'm talking, let's store hundreds, thousands, or tens of thousands of items in a single document, this is where I need to start thinking, hey, that might not be the right thing to do. For example, if I have an invoice for all of the interaction that you have over a period of time, and you may have a lot of interactions. A good example would be inventory management, or show me all of the cellmates made today, and all of them are done in a single document. If I have lots of cells, then this becomes unwieldy. Now, let's look at another business scenario. I have a product catalog, and I have many different products. Each one of them is different. Each one of them has its own properties. The shoe size and the TV size, TV inches, are completely different things. For that matter, I actually looked into that because of this presentation. There are male and female shoe sizes, and there are 4 different common numbering schemes. What the hell? I just don't know how to answer that. This is for something as simple as shoes. Now, I need to be able to query on that. Give me all of the red shoes. I need to go and conquer the result. So the question is, how do you do that? I need to be able to apply facets. Those are facets, like this. And this is how you can run these sort of queries. Give me shoes between those sizes, and apply facets on the brands, on the price ranges, on the condition. You can see how this looks like here. Now, the whole idea is that this is something that you do on a fairly frequent basis, searching data, computing those sort of aggregation of the data, or those sort of facets. And with a relational database, this is awkward and hard. If you're trying to do full text search, and for product catalog, full text search is absolutely a must, then you have to learn quite a lot of details that are absolutely uninteresting if you just want to be able to search. Again, the whole idea is that, okay, let's apply this in one place as a single product. Because what ends up happening in most cases is that you have a search index, Solar, Lucene, Elastic, and then you have the system of record. And you have quite a lot of issues in reconciling the data between them. Let's talk about another example, import-export. And this is where it gets really interesting, because one of the major problems with import and export business in general is the sheer complexity that is involved. The number of regulations that you have to navigate. I want to buy eggs in Egypt and sell them in France. No idea if this ever makes sense, but let's go with that. The number of regulations and rules that I have to follow is staggering. For example, if I'm trying to sell eggs in Israel, there is a maximum price I'm allowed to sell that. If I'm trying to transport them across the sea, then I have to make sure that I have the appropriate condition. Maybe they need to be refrigerated, maybe they need to be monitored, whatever. So the problem now is that when I'm saying import, export, tracking, or business, or whatever, I'm not talking about a single scenario. I'm talking about dozens. Each one of them has their own business processes and regulations. For that matter, the regulation differs between locations. And I may need to apply different set of rules in each one of them. Now try to imagine what does it mean to add a new destination or a new type of items that I'm export import. What is involved in doing something like that? And the answer that in most cases what would happen is that I would spend a lot of time trying to come up with a generic schema of the data, one size fits all. You can imagine how that goes. It's complex and it's fragile, and eventually you're going to break it. You're going to have a scenario that you didn't conceive and you can't adapt to. But if you can model your data differently on a case-by-case basis, suddenly you're far freer to work with the system. Or you need me to track the temperature of the eggs that I'm shipping. Sure, no problem. I can do that. For that matter, RavenDB has time series support, so we can do that natively. Here is the set of temperature that I recorded over this trip. Enjoy looking at that, I guess. Other things that I can look at is one of the complexities in import-export is that the cargo may sit in some warehouse doing absolutely nothing while there are non-trivial business processes around that. Getting out of customs, transferring legal ownership on that cargo. Apparently, by the way, there are art pieces that are held in warehouses that are sold between people who never saw the art, who never have access to this. Presumably a sort of an investment or something like that. So the issue is keep them in place, but now you have to have the processes of selling, verifying, moving, not moving, sorry. That's the key aspect. You may never move the items that you sold, but you have to keep track of a lot of that. And the issue here is that the backend need a lot of flexibility. And in most cases, as a developer, my rule is that I don't understand any of that. I need to go to a domain expert. I need to talk to them. I need to make sure that we do what they tell us. Because in some cases, the penalties for missing stuff could be very harsh. If I'm importing over the counter drug from place A to place B, where this is a controlled substance, you can imagine this is going to be a very bad day for me. The other issue here is that if we have one-to-one mapping for the data to the business, I can talk directly to the business expert, to the domain expert, and I can make the relevant changes. Otherwise, I have to go it in a really complex way. I have to translate the system from the database representation to the business representation. They ask for changes, and then I have to map it somehow to what goes on the system. in the underlying database. Now, I think this is almost the last one. That's a busy scenario that I want to explore. And then I want to get some time to talk to you and see what other scenario system you have. I want to manage a rental property. And it doesn't look too hard, right? What do I need to do? Where there is the lease, the terms on the lease, whatever you're allowed to pay, stuff like that. There are the people who are signed on the list. There are people who are included, like children. And then you have a whole bunch of related data. Or the babysitter is allowed in, don't need to worry about that. This guy is smoke inside the building is banned. Tracking of deliveries, a bunch of other stuff like that. Now, probably payment tracking, there's a lot of pictures somehow in rental properties. Or I took a snapshot of your garbage, it's not stored properly, $50 fine. Oh, here is the package that we delivered. You have to sign for that, so we take a picture of the signature as well. How much further stuff like that? But I think that what is the key aspect in terms of freeing yourself from relational modeling is about the free model aspect, modeling free. Let me explain what I mean. I have let's say that there is a babysitter, and I want to register that babysitter as an allowed guest. So I just do that. I create the allowed guest document and handle that. Now, here is a problem. This babysitter can babysit for multiple families in the building. How do I manage that? And the natural inclination is to say, you know what? I have to create a third normal form. I have to create the guest and the guest to a lease association and a bunch of other stuff like that. Turns out that this is actually really, really complex because an allowed guest may be allowed on certain dates, certain times, but they may be different for different apartments in the building. And now we have to think, how would I model that using pen and paper? And the answer is that I would have a couple of stickers. Let's say Samantha babysitter is allowed to C4 and Sam babysitting is allowed to D6. They happen to be the same person, but from my perspective, two different notes on the wall. And that leads to a very interesting observation. We have data redundancy here. Shouldn't we worry about that? Shouldn't we try to fix that? And the answer is no, we don't want that. We actually want to be able to consider the system as if it was made of paper. But why? What's the point? And the point is actually very simple. I want to think about if I'm working with physical files. I can add notations. If I'm working at the school, then I can put a big red sticker. This guy is allergic to nuts. If I'm doing that in a computer system, I have to account for that upfront. But if I have the ability to model freely, that's just something that I can do. That's easy and simple, and it ends up being a very successful system to work with. And now, before we get to the actual questions, the whole point of this webinar was to get you to think about how often we are constrained by the sort of mindset that we have. That, oh, it has to be this way because this is the only way that I can conceive of it. Now I believe we have a question. Not yet. Okay. So as a reminder, we have RavenDB Cloud, and we offer a free instance that you can start using. And you can also request a live demo, and we'll go and look into your exact system and try to help you build the best system that you can have. So we have Bezad Eslami. I hope I'm pronouncing this properly. What are the cons? Well, from the point of view of your system, especially if you want to be able to model freely, you have to make the system more flexible. Because if your system is still hard coding the structure of the data, then you're not doing so well. You can't get all of the flexibility. Let's talk about this. I want to be able to mark a file, mark a document as, hey, this the people on this list have nuts allergy, or whatever other notes I want. I have to be able to build that into the system. But it turns out that in many cases that isn't too hard, to the point where you give them the ability to say, hey, let's just add some additional data and dynamically add it into the system. Because again, the whole idea is that we're able to do things dynamically. Okay, we have Dejan Milikic. Are you aware of any cases of business domain implemented in parallel with relation and NoSQL databases? This is actually quite common. And the reason this is quite common is because in many cases, people use a NoSQL, non-relational database, to solve a particular problem. For example, you may store some of your data in Redis to be able to quickly access that, while some other data is queried through Elastic. Those tends to be hybrid systems where the data is spread over, and you have limited ability to query over the entire data set. The reason this is interesting is that in many cases, those things represent acknowledgement of the limitation of the relational system. Because I cannot fix this. I cannot, I need to have some additional data on this, on the rental property. But I cannot do that in the relational database. It's too complex to change that. It's easier to set up a whole new system. And it's crazy, but it is sometimes easier to set up a whole new system just to get it to work. In those cases, by the way, the typical scenario is that while you're running, while you're thinking, oh, I have a system that is composed of multiple databases, what you actually have is a single data set stored in multiple locations. And your application is now the persistent mechanism for the entire thing. That tends to work on an ad hoc basis and not something I would generally recommend. It's much easier to use a single system that can handle the whole thing. Okay, more questions. Do you want to bring up some business scenario, and I can try to have a go at analyzing what sort of different options you have when we're modeling things on a document database. Okay, we have Alberto Leon. I've worked with MongoDB and Cosmos DB, and just as basic as with Azure Blob Storage with small search. Same with Redis or Lucene. What makes RavenDB an alternative? Well, a few things. Probably the number one thing that I would mention is that for the most part, RavenDB was explicitly designed for your benefit. Now, this sounds like marketing speak, and this is annoying, but this is actually a key aspect. We explicitly design RavenDB to make sure that it gets out of your way. And that means, for example, a query language that is very similar to SQL. Consistency rule that are easy to follow. We have multi-document transaction. We always had multi-document transaction. When you need to query the data, then you're not limited to you're not limited to predefined indexes like in Cosmos, which may be extremely costly to generate. And you don't have to maintain your own indexes like in Mongo, where they can be quite complex to build properly. RavenDB says, hey, I'm going to be dealing with all of that. Give me your queries. I will manage the optimal way of doing that. I think that is one of the key aspects. A lot of the other things are about a huge swath of different semantics. For example, and this is honestly the most trivial example I can think of. When you say, give me the first page of results from the system, RavenDB will give you the first page of the results and also the total number of items in this query. So instead of making 2 queries to database, you only have 1. We have a feature called include that allows you to get related information in one shot to the server. This makes things a lot simpler. Now I can tell you that according to our metrics, we have 95+% retention. So people start using RavenDB and they keep using that and increasing the usage over time. They're happy with us, they're happy with the ease of use, they're happy with the stable pricing model. Across pretty much almost all of those, I think that would make a big difference. Now, something that you might want to look at, we published a white paper a few weeks ago. And in this case, we're talking about a real world usage scenario of RavenDB versus Cosmos DB. So RavenDB versus Couchbase. And that might give you some interesting details about the differences. We have Adam Shentag. How do you get people to move away from relational database management system and see the value in NoSQL? Well, to start with, I talk to you. It really depends on who the you that you're speaking about is. If I'm talking to me, then blogging, posting, article, that's the way I go. Inside a particular project, or if I'm putting yourself in your shoes, a lot of the things that are relevant is saying, hey, let's give it a shot. We're now in POC, we can get it started. We want to just get started and running. And at least for RavenDB, one of the key factors that we have is that we want to get out of your way. And we want you to just, again, we have some features that are, I keep repeating because they're that important for the quality of life. When you run a query, RavenDB will use the appropriate index. If no such index exists, it will create that. And just that means that you don't have to worry about indexes. Just that means that you move forward and you never even gave it a thought. I'm actually quite upset sometimes because I see people making use of RavenDB and seeing some of the productivity features, and they never even noticed that. The people who noticed that are people who used some of the other items, some of the other databases, and they felt upon it, oh, suddenly I'm not feeling that. And I think that that's a key aspect. So you want to be able to say, okay, let's move the data into Raven. Let's see what we can do with that. RavenDB has an import wizard from relational database. It has ETL to write to a relational database. So it's not as if you are just going to flip the switch. There's very good story around integration, both into and out of relational databases. So we have Nelson Souza. For you today, what are the biggest problems in adopting a NoSQL as the main database? Are people still afraid? 10 years ago, people talked about, oh, I need to have a scale-out story. I need to be able to run on multiple nodes. SSD and NVMe basically got us to the point where I can run almost any workload on any machine that I want. It's just about writing your system properly. But the aspects of moving to a NoSQL database, to a non-relational database, I think that the biggest issue is the mindset. That's why I have this webinar today. I think that for the most part, people bring the relational mindset with them when they go into other databases. And that leads you to try to use RavenDB as a document database. It's not going to work. There are certain things that RavenDB is explicitly designed not to do. For example, we will never do a table scan. That has awesome implications for the health of your system. But if you actually want to be able to do a table scan for whatever reason, that kind of sucks. One of the reasons that you might want to do a table scan if you want to do a dynamic aggregation. So you can use facets for that, but again, that means that a feature that you might even think, oh, this is simple. Now you have to understand that you have to do this in the proper way. I think that's the biggest problem. But again, a lot of that is just awareness of knowledge of what you have. So we have Nick de Bedot. I'm hoping I'm pronouncing that properly. How does query performance compare to relational database in general when dealing with large datasets? I'm very happy that you asked. In this case, this is RavenDB. This is RavenDB using 1.35 billion documents, and the total size of the data was over a terabyte. And we had queries similar to that. And where is it? Now you can see this is a 30,000 requests per second. And we are processing things quite nicely. Now, this is where we're doing an interesting query. Well, not that this will give me all of the highlights for a particular user and book. This is RavenDB hitting 15,000 requests per second with the 99th percentile at 200 milliseconds. Actually, the 99th percentile is here, basically 0 millisecond. But around here, we start seeing it crossing the 200 milliseconds. So this report is dealing with how does RavenDB deal with large data sets, comparing us to a Couchbase in this case. But the idea is very similar. And in the up to the single digit terabyte range, 5 terabyte, 10 terabyte, something like that. That would be something that I would just say, just run it. There's no worries about that. And just to make sure it's going to perform beautifully. We have Behalion Negash. Hey, thank you for the presentation. I just want to ask if you still have the embedded version that can be used for embedded devices. Yes, you can run RavenDB in an embedded mode. You can also run RavenDB in something like the Raspberry Pi. In fact, I think I have it here. Here you go. Just to give you some idea, this is RavenDB handling. I think this is 500. Here you go. 500 queries per second. And you can run it as an embedded instance. That means that it is running only as long as your application is running, and it gives you the full access to the RavenDB capabilities. In fact, one of the things that make RavenDB interesting in embedded scenario is the ability to connect and share data with other instances, either in a mesh configuration or a hub and spoke model. So that is a very powerful ability because RavenDB is a multi-writer model. So you can have multiple nodes all writing their own documents and merging them together, and that gives you a final result across all of them. Okay, do we have any final question? I think that we are done. So everyone, thank you for showing up. I appreciate you showing up. I hope that you enjoyed the webinar. If you have any additional questions, feel free to ask me. This is my email. Thank you and have a great day.